So now we're going to be talking about Entity Framework Core 1. Entity Framework is the way that we would connect an ASP.NET application to a database. It's sometimes called an ORM, an Object Relational Mapper. We've been using Entity Framework for a long time, since 2008, so it's gone through 6 versions, iterations. This latest version is a brand new rewrite, which works cross-platform, and we're going to be looking a little bit into how you would use it in ASP.NET Core to build ASP.NET applications. So, as I say, it's an object relational mapper. That's sometimes what it's referred to, or an ORM, a way of connecting your C# code to a database. And what we're trying to get is a productivity benefit from using this, so that we're not actually having to write our SQL database necessarily, and we don't have to write all the CRUD code, all the code to kind of connect our C# classes and our model, or the C# version of our model, to our database. So this is just someone which wants a quick way of connecting their code and their model in their application to a data store. They would use something like Entity Framework. Now, Entity Framework 6 is the current released version of this thing. So it's been around for a while, since 2008. It's actually the same time that President Obama there was elected. So it's been around for quite a long time. It's been used in lots of projects. I used it in my old company before I joined Microsoft, at Misco, when I was a developer there. We used the very first versions of this stuff for Entity Framework. And in its initial versions, in EF1, it was quite a poor product in that it would generate very complex SQL. It would generate very poor performing SQL. And our DBAs at the time, database administrators, were kind of unhappy often with the kind of code or the SQL that Entity Framework would output. It was also very complicated from a developer point of view, lots of EDMX models and so forth. Well, fast forward to today, and if you're using Entity Framework 6, you'll find that the SQL that it generates is generally very good. It's certainly better than the kind of SQL I could write by hand. And it's generally providing that productivity benefit that was always the promise of Entity Framework nowadays. And the last 3 or 4 editions of Entity Framework have been able to do that. And it's certainly grown up from being a very kind of basic conceptual idea where there was lots of ORMs in the .NET space, to now being kind of most people's preferred ORM, or at least one which is used by lots of people. And it's production ready, it's battle hardened, and it's well optimized. Fundamentally, when you're writing against Entity Framework, you're going to be using a lot of LINQ. So this is the kind of fluent C# syntax that you'll be using to interact with the objects that belong to Entity Framework. It's the recommended way. Entity Framework 6 is the recommended way of building or connecting to databases, specifically Microsoft SQL Server, obviously, using Entity Framework 6. And it's battle hardened. Lots of websites are using this in production, have been using it for years. So Entity Framework 6, as it stands today, very solid product, very performant, does its job and does it well, and is the recommended way of doing it. Now, I don't know about you, and you can't see me at the moment, but I do have quite poor grey hair. And most of that grey hair started in around 2008 when I first worked on EF. Now, I don't know if President Obama is an EF developer in his spare time, but there is some coincide. It does coincide that he does have this grey hair. So I don't know if he's working on White House projects on ASP.NET or not, but EF is certainly the reason for my grey hair, if not President Obama's. EF Core 1 then, this is the new thing. So EF6 is what's being in production today. People are using that today. EF Core is the new kid on the block. It was previously called EF7, but we felt that was a confusing name because it implied that it's the next version of EF. And whilst it is the next version of EF, it also is a very different version of Entity Framework. And we didn't want to give people the impression that it was somehow you would just be able to switch from EF6 to EF7. So we announced that it was called EF Core 1 to sort of separate it and show that this is a slightly different path. EF6 will continually be updated, and there'll be revisions of that ongoing, because people will still need some of the features. EF Core is something which we're starting now, and it will eventually have feature parity with EF6, and will be the recommended way of doing databases, regardless of platform. But at the moment, EF Core is pretty much the way of building these ORMs for applications which are required to go cross-platform, which is something that EF can't do, EF6 can't do today. So it's a rewrite. They started from scratch, a complete sort of a new code base, and the attempt was to try and look at the benefit from all of the learnings they've had with EF6 and all of the features and the battle hardening that they've done there, but start with a clean slate and not be tied down by the history. So it was an opportunity to change the way that APIs worked. It was an opportunity to improve some of the things that people had been saying that when customers had not been happy with current versions of EF6 with. So things like the speed and performance of EF Core. There was an opportunity here to rewrite and rework it so that it would perform much better than we were able to achieve with EF6. There's lots of things, lots of benefits of EF Core and reasons why you might use it, and we'll get into those in a moment. I just want to try and talk about what the reasons why EF Core exists, and one of the core goals of this thing is that it's cross-platform. And by that I mean that if you're a web developer developing ASP.NET applications, this thing will be able to work in ASP.NET applications that run on Windows, on Linux, and on Mac OS. On OS X, sorry. And the kind of, it's going to be able to run on a lot of those different platforms, but also it's going to be able to run in places which aren't the web. So previously Entity Framework's been the ORM for ASP.NET applications, but it's now becoming the ORM for all kinds of .NET applications. And the view is that it will be the ORM for, and you currently can do this with the Universal Windows platform. It will also be the data store for Xamarin and lots of other places. So you'll be able to use your EF Core models in lots of different places, not just in ASP.NET. So it's cross-platform. And not just saying cross-platform as in the places where ASP.NET can go, but also cross-platform in the way that it can go into pretty much anywhere that .NET Core can go. So Xamarin, Universal Applications, and probably more places in the future as well. Traditionally today, EF6, that targets Microsoft SQL Server, and lots of people want to target different databases. We have lots of different providers which you can target. So you can target not only things like, there's going to be very shortly a MySQL provider for Entity Framework. You can do SQLite. If you're building Universal Windows applications, that might be useful for that, or Compact Framework. But also, we are going to add support for NoSQL data stores as well. And there's been some prototypes built around Azure Table Storage and Redis. And the idea being that you can use Entity Framework to access any database system, whether that be Microsoft SQL Server or any relational database, but also a NoSQL store as well. The idea is that it's also, when you're writing this, they're focused, or you can tell from the kind of progress that they're making at the moment, that they've kind of focused on the code-first avenue of developing these EF Core data stores. So what I mean by code first is that you would write your C# classes and your model and generate that first, and then you would generate a database from that. We call that code first. There is another way of doing this called model first, and we have support for model first, but it's not quite on par with what we have in EF6. So you can, a one-time snapshot, you can take the model, the database, and convert that into your C# classes and work from the database first to generate the code. But there's no real simple way at the moment to just like regenerate your code once you've done it. It's like a one-time operation. So the avenue at the moment that's beneficial for EF Core is that it's kind of focused on code first. That might change going forward, but it's at the moment, certainly if you're using these bits, then the code first is definitely what's in all the documentation, and it's the way that you'll see most of the demos done. I mentioned NoSQL. There's not currently an implementation of NoSQL like in the box in terms of it's not something that you can quite. It's not. You can go down and get some of these. You can go down and get a. There are prototypes of this stuff working against certain of these stores, but I don't think any of those at the point yet of maturity where people are like, you could use this in your application and not worry about it. Also, don't think that this is just a case of flicking a switch and suddenly your MySQL Server application can now run on Azure Table Storage or on some kind of NoSQL data store just by flipping a switch. There's no magic that we're implanting to make a non-relational data store into a relational data store. There's no magical abstraction that we're doing here. You will have to write different code if you want to target a non-relational database versus a relational database. And depending on the provider that you're choosing, there's going to be more or less code changes that you have to make, but certainly the differences between NoSQL stores and SQL stores is going to be it's not going to be just a case of just pointing at a different provider and your application will just completely work. So you will code against these things in different ways. We're not adding a relational concept to NoSQL stores because that would be probably madness. So if you're using EF6 today, you have an EF6 application maybe, and you're thinking about moving it to ASP.NET Core, and you're thinking, should I migrate to EF Core as well at the same time? The answer is probably no. If there's a few limitations to what's in EF Core at the moment. There's the basics of getting started and building a database and all that stuff. That works, and it works really fast. It's very performant. But as you get more complex sort of edge cases, certainly the sort of stuff that we were doing at Misco, we would probably come against the hard edges of EF Core at the moment. There will be a point in time, obviously, when EF Core does become the way that you build ASP.NET Core applications. But at the moment, if you don't need to go cross-platform, then you probably should be using EF6. And in an ASP.NET application, you can use easily EF6 or you can use EF Core. The limiting factor of EF6 obviously is the fact that that only will work on Windows. So if you need to target any of the other platforms which are not Windows, then you're going to have to look at EF Core. So let's have a look at what it's like to use EF Core in an ASP.NET application. So, and create a new project. File, new project. And I'm going to choose an ASP.NET Core web application. I'm going to build it on .NET Core. So this is the cross-platform .NET. This resultant website will be able to go lots of places. My demo EF, we'll call it. Press OK. I'm going to choose the web application. So this is the sort of starter template, if you will, for ASP.NET Core. I'm going to change the authentication to no authentication. The reason I'm doing that is because if I chose to add authentication, the application would have already added Entity Framework for me. And I don't want to do that. I want to add it to show you how you would add it to a vanilla sort of plain project. So we'll create this My Demo EF project. And hopefully, here we go, it started. It's restoring my NuGet packages. And we are going to add a NuGet package to this. We're going to add the Entity Framework NuGet package to our application. So if I right-click the application and say Manage NuGet project, NuGet packages, and then I search for, on the Browse tab, if I search for Entity Framework Core.SQL Server, you'll note that I've got this include pre-release ticked. That's because this stuff is not ready yet for, it's not RTM'd yet. So we're still working in pre-release. So I'm just going to see if I can just move that down a little bit. We're going to install that in my application. It's going to ask me to accept a license. And of course, like always, I never read the license. Probably should. Once that's installed in my application, I've got EF in my application. So now I can start adding a model. And for the purposes of this demonstration, a model is a single file. So I'm just going to call it world. World. Add that to my application. And rather than me writing down a Poco class, I will just EF demo class. And you'll see I have a town class and a resident class. And I will also add to this class a property, and it will be a list of type resident, and we'll call this residence. There we go. Now, obviously, when this creates in SQL, it's going to create a relationship now between the town and the residents, which are included in it because I've added this list. So we'll save that there. It's asking me to resolve, it's giving me some red underlines. It's because I've not resolved the using statement. So I'm going to add the using statement Microsoft.Entity Framework Core to my application. And now I've got a DB context added to my application as well. So now that we have this context, the question is now, how do we get this added to my actual ASP.NET Core application? Well, in startup.cs, we have a area called configure services, a method called configure services. And this is where we set up lots of different services which are going to be used by our application and all the kind of dependency injection stuff that we're going to require. So if I just go and add in the services snippet to my application, I'm just going to resolve this. It's saying that it doesn't know what that useSQL server is. I just need to make a reference to the using statement. And what I have now is a connection, which is going to a local database, my local server. It's going to create a database, connect to a database, sorry, called world. And it's going to just use the trusted connection, so basically my user credentials. So it's going to be logging in as me, and I'm going to be running this. So this connection string obviously would be the connection string to your actual SQL server. At the moment, I'm just using a local version. And I was saying server, add DB context, add that world context. And the options that I'm passing in to it is the fact that I'm using SQL Server, that's the provider that I'm using, and I'm passing in the connection. And what this is going to do under the covers is it's going to set up the dependency injection for Entity Framework so that I'm able to get access to that context, that world context, from wherever I am in my application. So what I want to do now it's a little bit, I don't know, a bit ropey at the moment in the way the developer experience of this at the moment, because I'm going to have to drop out into command line. Now, of course, when this thing is finished and the tooling is up to date, you won't have to drop into command line to work this stuff. It's just the kind of way that most of the teams seem to be working in ASP.NET and around that area at the moment is that they write the command line interface stuff first and then it gets integrated into Visual Studio later. So because this stuff is pretty hot and pretty new, they're currently at the point where the command line interface does pretty much everything you need it to do, but the Visual Studio tooling is not quite up to par. So we're going to have to drop out and do lots of stuff in command line. Don't let that scare you, though. It's just one of the cool things is that's another way that you can interact with this thing for your build processes, perhaps. It makes it easier with a decent command line interface. But you will have a nice Visual Studio experience at some point in the future as well. So if I just go into here, right-click, and I'm just going to open up the file folder in the folder. And if I just type CMD into that little thing and type it up there, it'll open up the command prompt at that location, which is where I want to be to run some of my EF commands. Now, .NET, that's the command line interface for .NET. And we can do all sorts of stuff like building .NET applications with that command line interface. So the EF command line interface is a command which is built on top of it, so that you use .NET, and then you type the word EF in it. Now, if I run that .NET EF, I'm going to say no executable found matching commands at the moment in this application. That's because I've not installed the command line interface at all. And to do that, it's a two-step process. One thing I'm going to have to do is install a NuGet package. So let's go over to NuGet. And I'm going to go Entity Framework Core dot tools. I'm going to install that. Accept. And that's going to install into my application. And then the other thing that I'm going to need to do is go into project.json. And I'm just going to add that tool, or that NuGet package, to my project.json file as well. So this shouldn't be called, I've just copied that one for the speed, but I'll just go entity framework core dot tools. Like that. Uh-oh. I think I've messed that up a little bit. Let's have a look. Oh. Tools. Try that again. Build solution. And then if I go in here and I type EF, you can now see that I have those EF tools in this project. There's a little bit of ASCII art. That's always a nice thing. I think that's a unicorn, isn't it? It shows you the commands that are available in this command line interface. There's a help system, so -h is help or -- help. So I am going to now run a command, which is .NET EF migrations add. I'm going to call kick this off. I'm going to run that against my database or my application. And that's added a migration to my application. So what is a migration? If I go now to my folder, you'll see I've got a new folder called migrations. And we have the world context model snapshot. And we have this migration, which we added. It's called, you see that's prefixed there, kickthisoff.cs. And what this migration shows or explains to EF is, okay, how do I create the database? And it has two methods. It has an up method and a down method. And the idea is that as you make changes to your model, to your C# files, you add new properties and things, migrations are a way of describing how to create or move your database from one position to another. And so you might have 10 migrations in an application, and they all build on top of each other. So if someone is at migration, the second migration you've done, there is a way that the system can figure out, well, how do I get from migration 2 to migration 10? Well, it runs migration 2, 3, 4, 5, 6, 7, 8, 9, 10, and then it's in a known state of the database being at the right position, it's got the right columns and so forth to it. And the way it does that is that each migration has an up method and a down method. An up method which gets it to the current migration, and a down method which takes away the migration. So you can remove a specific migration and roll back effectively. So you'll see that in this instance, the up migration, it creates a table called towns. It puts all of the different columns in there, which are in part of my class. It adds the constraints that are required. It then creates a residence table, and it's creating the thing like the town ID, the fact that there's a relationship between the towns and the residents of that town. It's creating an index for me. And then the down method, which basically removes or undoes what the up method does, which it just drops the table resident, drops the table towns. So now if I run .NET EF database update, what that'll do is compile and figure out the database structure, get to the right migration, and then put that live in the actual SQL database. Took a little bit of time there. Obviously, it was actually creating a real database. So if I refresh the database there, and look, now we have the world database. We have some tables. We've got the residents table and the towns table, and they currently contain nothing. So what we're going to do now is put some data in this database and connect it up so that we can actually start using it. One of the things that we can also do is .NET EF database drop. And it'll say, are you sure you want to delete the database? Yes. So rather than doing it directly through SQL, the SQL Management Studio like I did there, you could do it from command line as well. And all this does is we run a command on the API which ensures that the database is created. So this will only create the database if the database is not already in existence. And then I'm going to add a number of towns to the application. So I've got Corby, which is my hometown, and I'm going to give an arbitrary rating of 10 out of 10. I don't live in Corby anymore, but you know, my home is still, my heart is still at my home, even though it's not the world's greatest place. Never mind. Droitwich Spa, which is where Martin Kern is from. We're going to give that a rating of 3. Never been there, but I can only imagine that a place that Martin Kern comes from can only be worse than somewhere I was born. Then Reading, which is where Microsoft is based in the UK, which is where we're presenting from today. And we're going to give that a rating of 4. It's probably better than Droitwich Spa, but it's still made of all concrete, so I'm going to give it less than Corby. And then I'm going to add some residents. So town resident number 1 of Corby is me, which is Martin Beebe. So I've added a new list, then I've added a new resident, then I've added Martin Beebe. And then resident 2 to town 2, the second resident, is Martin Kern. Now, what I then do is I've added, in 2 different ways, I've added the town, the first 2 towns. Now, the only reason I've done it in 2 different ways is to show you that you can do it in 2 different ways. So with this add range, I've added a range of objects, a list or a collection of objects, so town 1, town 2. And then I've explicitly went to the towns object and then added a new town. So you can just add it to the context of the object, or you can say explicitly, this is a town object, and I'm going to add it to the town as well. This will result in exactly the same SQL. It's going to know that, okay, that's a town object, so that needs to go and connect up to the towns database. But it's just 2 ways of doing kind of the same thing. One adding a single item, one adding a range, and kind of adding it at 2 different points in the database. What's interesting about EF Core is when this actually inserts into the database, it's going to run one single SQL statement for that insert. Previous versions of EF would have done 3 different inserts for that add. But it's clever enough, EF Core, to recognize that it can do that insert in one pass and one connection to the database. So it will do, and we'll hopefully have a look at that when we trace it later. There is a kind of a bit of a weirdness at the moment, and I actually don't know if this is going to be changed, or certainly from the GitHub repo, it's not completely clear to me as to what you're meant to be doing here. But I've added already those residents to my town. In previous versions of EF Core, by just adding those towns, because they had the residents on them, and then calling save, the sort of graph would have been persisted. All of the residents would have been persisted. At the moment, it seems that we have to add the range. And looking at the GitHub issues, people have raised this as a sort of change in the way that the API works. And they allude to the fact that there might be an add graph or a way of changing it. I've not been able to find the way that you sort of determine or tell EF Core that you want to take all the dependencies in the graph as well. So what I've done instead is just quickly added the residents of town 1 and just passed the collection of residents and the collection of town 2's residents and added them individually as part of my seed method. Sorry, when I say seed method as well, that's a slight difference. In EF6, you will have had a seed method, which is when the database is created, I want to seed it with this basic data. I've got a sort of, this is my sort of seed method, but there's not actually a specific point at which you can call this seed method. So I'm just going to add it arbitrarily into my application. In the roadmap for EF Core, they do say that they're going to add a seed method, like a specific point at which you would add all of your seed data. And then ultimately, I'm going to say save changes. So it will go and add these 3 towns, it will add all of the residents of those towns, and it's going to save changes, and it's going to persist those things to the database. But it's only ever going to do this when the database is created. Now I've added this as a public void onto my context, so create database and seed if none exists. So I need to call this thing because, as I said, there's no seed method at the moment. So I'm going to call it in probably not the greatest place to call it, but it will work. So that's what I'm going to do. I'm going to put it in the configure section. So we looked at this configure section earlier in the day. This is ran at the start of the application, and it sets up the pipeline for the application. So I'm just going to call it here, just for want of a better place to perhaps put it. I need to get access to the context though. And I mentioned here before that when we started adding our services to configure services in this startup.cs file, this is adding dependency injection. Well, let's see how that dependency injection actually works. What I do on this method and on any method throughout my application or any controller perhaps that I want to use this, I just say that there's a parameter called world context and it's going to be of type context. And what will happen is the dependency injection system, context, the dependency injection system is going to recognize that parameter. It's going to know that it's got a way of fulfilling that dependency, and it's going to inject the context which we're using in our application into that method. So I can then just call context and call my create database and seed if none exists method. And so on startup of this application, if the database doesn't exist, it's going to create it and then it's going to seed it and populate it with a bit of data for me. So let's start that. So it's going to be quite slow for obvious reasons. I'm creating the database on startup of my application. This is not recommended practice, but it shows that we can do it. And when the database has been created, and it will have seeded with some of our data, it will load up, and we can then look at our actual our database. And if I select the top 1,000 rows from this now, you'll see that the residents now, it says Martin Beebe and Martin Kern, and it has a link to the town ID, town 1 and town 2. And if I go into the towns table and select top 10,000, top 1,000 rows, you see Corby, Droitwich Spa, Reading, and it's giving the ratings there as well. So it's worked, it's done as we wanted it to do, all is good. So how do we actually then use this data, or how do we access this data now that there's some data in our database? So if I go and close, I'll just close this for the moment. And what I will do is inside the home controller, in the in the index file, that'll be fine. So the actual application as it starts and then runs into the index application, we will start to use this this new database. So what I want to do is obviously I need a way of accessing the context. Well, we can do that by saying public and just adding a constructor for the home controller. Like that. So this is going to be the constructor for this controller. So when the controller is created, I'm just going to say world context, like that. And then I'll just have a this dot context equals context. I'll just create a bucket, generate the field there. So now my controller now has a private reference to the context so that I can start in my application calling this context. So I can say something like context. Well, actually, I'll save it to a list for var list equals from C in context dot towns C dot rating is greater than 5, and then select C. So some link kind of syntax there, and then I'll just pass that to my view. Okay, now if I go into my index view, so where did I put it in inside of index now? Studio stopped a little bit there, never mind. I'm just going to delete this view. And paste in one which I already have, which is demo EF view. And there we go. It's enumerable of town in this view, and it will show my towns, and it will show all of the different towns which have a thing above. What did I actually put the database thing as? So anything, if I say anything above greater than 3, then I should get Corby and Reading back, but not Droitwich Spa. So I'll go back to the controller and just say anything above 3 rather than 5. There. And then I run this. And you'll see that it says my towns, Corby and Reading, because obviously it's calling directly from the database and it's asking for only towns with a rating above 3. So Corby and Reading are the only ones which are output. So we've kind of gone with the vanilla building blocks of EF. So let's go and have a look at how we customize some of this stuff to work in maybe the way that we want to. So if I go back to World CS, this is my DB context. And I'll add in here overrides space, and I will add in here I want to override a method called, I think it's onModelCreating, that's it. And here, inside of onModelCreating, we can kind of customize the model as it's created, as it's being built. So if I just, there's a parameter which is passed into the onModelCreating method called model builder, and it has access to all of the entities. So we can say entity, I want the entity type town, and we can say then its property. I'll put a little lambda in there and say, sorry, like that. T dot name. Dot is required. So it's just a quick way of saying, you know, this particular town has a property called name, and that's a required field. So if anyone tries to save anything to the database where it's not required, then you know, it won't allow that to happen. So ultimately, that's going to actually make a change in the database. So let's just delete. Delete the database again. I'll do that from the command line actually. Say, whoop, drop the database. Yes. And then I'll just clear my screen. .NET EF add migrations required. Okay, and now we've got a new migration in our application. Cool. And what it's done is it's looked at that and said, okay, the difference between the previous database and this new database migration is the town table on the column name, that's now nullable. So if I were to go into my database now, I'll just do CLS again to clear the screen, and said .NET EF database update, it should be updating our database. Boom. And then if we look at that inside of here, we'll see that the name is not null. So it is required. Now, if I go back to my database, go back to that world file, and we could do something like that same town file, but instead of having being called towns, maybe we wanted to have some other name for it. So we could say to table city, like that. And so now that town table will become a city table in our database instead of town. And that might be just because we want to maintain some kind of slightly different, we want to call it one thing in our C# application, but the DBA or the database people want to call it something else as well. Or maybe you have an existing database which already has a column name of that, and so you want to be able to maintain and map it to that thing. You might also want to do something. There's a thing called conventions or custom conventions in the ES6. It's not there in terms of what you have available for you in core, but there is a much nicer way of accessing some of the attributes or metadata about each of the tables. So I can do something like for entity in model builder dot get entity types. That's going to give me a list of all the entities in my application. And then once I've got that, I'll say model binder dot entity, and I'll pass over the entity name, which is coming from that list. And then I will change. So this is just a one map for town to call it city, but I could do something like entity dot CLR type. So this is the table CLR type dot name. And I can concatenate it with the word S. So town would become towns, and resident would become residents. You might have a naming convention where you want to call the class something in your application, but you want to call it something else in the database, and this is just a way of pluralizing it, and it's a very simple way of pluralizing it, of course. But there's this capability of getting or digging into the entity types in a much simpler way than was previously possible with EF. So now we can loop through the whole table and do or implement our own version of custom conventions. Finally, I just want to show you a quick thing called shadow properties. So we can also go to our model and say model builder dot. Oh, sorry, I missed a parentheses around that. That's why I wasn't getting IntelliSense then. And so I'm adding this property which doesn't exist in my actual my actual class. What am I talking about? .NET EF database drop. Now I have a new kind of string thing called alternative names, which doesn't actually exist in my class. So it's like an extra property, if you will. But this is still accessible, even though it's not in the classes. You can still access it. So we could say, where's our CRUD or our CEDA? So I'll give a different alternative name for each of these. So Plastic Scotland for Corby, because it's full of Scottish people, and some people call it Plastic Scotland. There was lots of Scottish people came down for the steelworks in the 60s. And everyone talks with a Scottish accent despite the fact that it's in the middle of England. And so we're often referred to as Plastic Jocks or Plastic Scotland. Droitwich Spa, we'll give that alternative name of Lido because that's its main feature. It has a Lido, and Martin Kern basically doesn't shut up about it. And then Concrete Jungle, which is my alternative name for Reading because it's full of concrete. If you've never been here before, it's slightly built up. So those are the sort of way that you access that shadow property by passing it into this and then calling the property alternative names. And then, because they are ordered differently, we could go into our controller and instead of ordering by, or in fact, by adding an order, we could say order by, and the syntax for this is a little bit weird. We have to ef pro, in fact, so weird that it's not going to give me a very good IntelliSense experience. ef.property string, and we'll pass in the context, see alternative name, like that, and then just resolve this using EF-core. And so what that should do now is we'll have to drop the database again. Sorry about this. It's my stupid fault for only recreating the database on startup. Oh, let's stop my application. Run that again. Yep, I want to drop the database again. And then I'll just restart the application or rebuild the app. And hopefully this time we'll have alternative names, but we'll also have it seeded with a bit of information. And we will have a different order for our names because it will no longer be Corby first because that's called Plastic Scotland. And it's ordering by that alternative name. So P comes after C for Concrete Jungle. So hopefully Reading will be first, Corby will be second because it's ordering by that name. So if we then look into our database now, refresh that thing, look into the table of towns and look at the columns, and we'll refresh, return the top 100 rows. We'll now see we've got this alternative name, which isn't part of our model, if you will, but can be called very easily. So there we go. That is, in a nutshell, how you're using EF-Core. So at the moment, we have a provider for SQL Server, SQLite, which is what you'd be using if you were building using EF-Core on the Universal Windows platform. Postgres, which is provided by the .NET. There's a .NET kind of wrapper around that database, and that's what we're calling into. And that's an open source, believe it to be open source sort of activity which is going on there. We've got the SQL Server Compat Edition, and there's an in-memory version of Entity Framework as well, because if you're doing testing and you want to test your code, which is using EF, and rather than going against a real database or even a local database, it's far quicker to do your testing against an in-memory database. So we now support an in-memory database for testing with EF-Core as well. And very shortly we'll have a MySQL implementation and an IBM, even DB2 implementation for our providers as well. And there will be more and more providers coming on stream from us, from some of the open source community, and there will be, obviously proprietary database providers as well, which will write providers for this platform too. So that's it. If you want to know more about Entity Framework and the roadmap and it's important as well, if you're thinking about adopting this, to be wary of the fact that there are some limitations to this new EF-Core. It's not as fully featured as EF6 at the moment. Most of that's explained very well on this roadmap.